The flux of the vector field, nicknamed F, with components 0, 0, negative 3, across the surface, that is the set of points in R3, such that z is 3 minus x minus y. Also, it says in the first octant, so I'm going to say x greater than or equal to 0, y greater than or equal to 0, and z greater than or equal to 0. I'm going to nickname that surface. I can nickname it whatever I want. I often go with R for a region or S for a surface. That's fine. I'm just going to go with R for a region. Okay. Now I'm going to make a which statement, okay, a parenthetical remark, which is parameterized by the function R, a function of two variables, u and v, since we need to have a two-dimensional surface here. I can do first component u, second component v, so u is playing the role of x, v playing the role of y, and then the last component is expressed in terms of the first two this way, 3 minus u minus v. Okay. On the set of u and v in R2, such that, now what conditions do we need to have on u and v? It looks like we need to describe the condition that 3 minus x minus y is 0. So let's, sorry, I misspoke, but let's draw this region of integration, okay? It is this surface, that is a plane, okay? And then I want to think about the floor, since u and v some region in u and v, this set is going to be taken over to this set, and the uv values are going to be taken, like there's one uv value for each point on this surface, which corresponds to one point in the floor. So I want to think about the floor. Okay. So we need to have v oh, that's 3. My mistake. Be less than or equal to 3 minus u. But also greater than 0. And then u in the interval 0 to 3. Sorry that didn't turn out very nice over there. Now the sentence is, the flux of the vector field across this surface is. It's the integral over that surface of f dot n hat dA, where n hat is the normal vector pointing up this way. Okay. Now I have u coming first and then v going second. If I point my fingers in the direction of u, that's the direction of x, and then curl them in the direction of v, then they point upward. So the normal vectors are indeed going to point upward off of this surface using that parameterization. Okay, so pulling back across this parameterization of the surface from an integral in x and y over to an integral in u and v, I replace the components of f. Anywhere that there's x, y's, or z's, I replace with these components, but there are none. This is a constant vector field. And now I'll calculate that normal vector. It's the cross product of the derivatives of this vector. Okay. The derivative with respect to u is 1, 0, negative 1. The derivative with respect to v is 0, 1, negative 1. Now I have a du dv. I also realized that I was thinking, like later on, much after this class, you don't think of double integrals as needing two integral symbols. It's just an integral. My mistake. Okay, so now integral in v and u. Let's see, I want to do v first and then u. So I'm going to go from v is 0 to 3 minus u. And I'm going to go from 0 to 3 in u. Okay. Section off my drawing here. Okay, so calculating, I have this integral 0, 0, negative 3 dotted with, let's calculate this cross product. The first component is 0 times negative 1 minus 1 times negative 1. Who cares though, because it's going to be multiplied by 0 in the dot product. Also, the next component I do not care. So I only care about the last component, which is 1 times 1 minus 0 times 0. dv du. 0 to 3 minus u. And 0 to 3. Okay, so our integrand is going to be negative 3 with dv and du. Integrating, I have negative 3 times 3 minus u, and that's inside of an integral from 0 to 3 du. That's an integral from 0 to 3 of 3u minus 9. And we'll get a 1/2 3 squared, and then a minus 9 times 3, which is 3 to the 3rd. Okay, so looks like the number here is 1/2 of 3 cubed minus 3 cubed, so negative 3 cubed over 2. And I'm going to do a sanity check. The direction of the vector field was 0, 0, negative 3. That's everywhere pointing downward. The normal vector pointed partially upward. It was this normal vector was positive in the z component. I'll calculate that middle component now. I realize I wrote a 0 just because it doesn't matter, but it is negative 1 times negative 1, that's 1, minus 0. So actually it should be 1, 1, 1. Oh yeah, that's easy to see from the beginning, right? Because this is x plus y plus z is equal to 3, so the normal vector was 1, 1, 1. So I could have done this quite a bit faster, I suppose.